Okay, guys, so we started the chapter, right, with talking about the figure that it was a circle and its perimeter, which we said is actually on a circle called a circumference, okay, the length around the outside. Then we moved on yesterday and we talked, or I should say 2 days ago, we talked about we kept the circle, keeping the circle, we talked about area, all right? We talked about the difference between the circumference and what an area is, okay? Today what we're going to do is we're going to kind of add on to that, but we're going to talk about different shapes. Okay, we're not going to talk about circle. Actually, you will see some circles in here, but we're going to talk about other ones besides circles, okay? However, these shapes are kind of some special shapes, so bless you. The name of today's lesson is called Area of Composite Figures. All right, so you might be thinking, well, what's a composite figure? Well, that's good because that would be our very first vocab word. Actually, our only word. So, composite figure, everyone? Composite figure. So, here's what a composite figure is. Your book says it's a figure that is made up of two or more three-dimensional figures. Now, that is a little confusing because while that's true, today we're going to talk about composite figures that are only two-dimensional. All right, so you're going to see that. So, the vocab word in the back, it gives it for basically like another lesson. So, today, though, it's only about two-dimensional figures. Same idea, though. So in your little box off to the side, here's what I want you to draw. I want you to draw that right there. That figure. While you're drawing it, guys, what are the figures that make up that composite figure?
Triangle and a rectangle.
Triangle and a rectangle, right? Triangle and a rectangle. Okay, that's what we're dealing with today. We're dealing with shapes that have more than one basic shape to it. All right, we're going to find the area of these types of shapes. Now, I just want to talk just a quick review on area, the whole concept of area. Remember when we talked about circles the other day? And I said, remember circumference, just like our POD, the circumference was the outside of the circle, but the area, right, is the amount of space on the inside. But remember, we also talked about how the way you measure that isn't by like a ruler. You measure it with two-dimensional shapes. And those two-dimensional shapes, remember, where we measure it to find out basically how many squares are inside of that space. All right? So, if you take a look at this, right? If it's the same idea, how many squares on the inside? Kind of give you a rough idea, but if I was to find out the area of this rectangle right here, and then in a separate problem I was to find out the area of this triangle, to find out the total amount of area, what would you guys do with the two areas? You add them up. So today, realistically, if you remember that, today is a big portion of today's assignment is its review. Okay, now there's a couple little twists and turns that I'm going to show you guys, I'm going to share with you during the lesson, but that's the basic part of this lesson. You're going to find the area of the different composite figures and you're going to add it all up. All right, so with that said, let's take a look at these examples. All right, so grab your book if it's not already out. Let's go ahead and turn to page 634. All right, so we have a shape that, if you're a basketball fan, kind of appears to be part of a basketball court, even though it's not. Okay, the little squares obviously are showing right angles, which is saying that it's telling us basically it's a rectangle. All right. Now, when I go to solve this problem, okay, when I go to solve this problem, I'm going to go ahead and do step one, and that is we need to find the area of, we'll just call it the first figure. Okay, now the first figure is of your choosing. Okay, more than likely, it's probably where most of us will go, is we'll go to the easier part of that, which is the rectangle. Okay. Now, when we find the area of the first figure, I've got to share this with you. Okay. This is extremely important. Okay, and this is the comparison, okay, that I usually make for my students every year. Okay, is if, let's say you're at home and you got a new picture, or whatever your hobby is, you have this wonderful, awesome picture, framed picture that you want to put up in your room, and you need to hang that thing, and the one thing that you have in your house is you have a nail. And let's just say it's a pretty big nail, and since the picture's pretty big, you have to put it into a stud, meaning into the wood part of your wall. Okay, so to be able to drive that nail into the wood, all right, I need to go out to my tool shed and grab a tool. Okay, those of you that are familiar with tools, what kind of tool am I going to need to drive that nail into the wall? A hammer. Okay, unfortunately, some students don't know what. So a hammer is that thing that, you have a handle and it has, the head, and it usually has hooks on the other end. Okay, that's a hammer. All right, so if I have a nail and I need to drive it in there, I need the correct tool. What happens if I go out to the shed, all right, and I have my toolbox, I get in my toolbox and I grab a screwdriver?
You're going to have a time hammering it in.
Now, I probably can hammer that nail maybe in for a little while, but once it hits the wood, more than likely, I'm going to, the screwdriver. And this is if I'm turning the screwdriver around and maybe using the handle. A lot of the handles are plastic. I'm probably going to hammer it to where the plastic just completely disintegrates. All right, bottom line is I'm not going to be able to accomplish what I want to accomplish. Okay? If I have a screw, now it doesn't mean that, right? It doesn't mean that a screwdriver is a worthless tool. It's an awesome tool for screwing in screws, right? But to nail in a nail, you need a hammer. You don't need a screwdriver. Okay? So there are lots of tools in my tool shed. I've got to choose the right one to do it. Now you might say, well, why are we talking about tools and hanging pictures, Mr. Wilkins? Well, here's why. Because today what you're going to see for the first time this school year is you're going to see that we have a bunch of things we have to accomplish, tasks, okay? And we have to choose the right tool to do it, or we're not going to get our desired results. Just like nailing in a nail with a screwdriver, not going to happen, right? If you use the wrong tool, in this case, the wrong formula, you're going to get a bad answer. You can do a bunch of work for nothing. Okay? So listen carefully. Here's what I'm talking about. Our formulas are our tools in our tool chest. All right? And our toolbox, tool chest, our shed basically is this thing right on top of our neck called our head and our brain, right? That's where we need to pull out the correct tools. A lot of people fly through their homework or even their tests and use the wrong tools. And they end up getting the wrong answers, doing a bunch of beautiful work, but they get the wrong answers because they chose the wrong tool to use. So here's what I'm getting at. At the very start, bless you, at the very start, make sure you choose the right tool. Since I'm dealing with a rectangle, I'm going to use a rectangle formula, the area of a rectangle. Now, you guys know it, of course, in elementary school, it's length times width, but we're going to start calling it base times height. Okay, base times height will also work on parallelograms. Okay, so we're going to start using that formula there. Now, when we go to solve this area, right, we're going to plug in our base and our height. Now, the height of this is right there. Nice and easy. It's 2 feet. So I'm plugging in 2 for the height. However, the base, some people will look at this and say, well, the base, Mr. Wilkins, doesn't have a number. Well, this is where some of those little twists and turns in our lesson today, you need to start using some knowledge. And I know that because these 90-degree angles are here, this is a rectangle. And because this is a rectangle, its opposite side is congruent. I mean, it's the same size. So if this, bless you, this line's 1.5, that means that this line is 1.5. And if that's 1.5, that's our base. I'm going to plug in 1.5, 1 5/10. And then I go ahead and simplify that side. And the area of that rectangle, ladies and gentlemen, if I take 1.5 and double it, that's what multiplying by 2 is. It's like having $1.50 and another $1.50. How much money do we have? $3, right? Bless you. So the area is 3. Okay, now step 2 is we need to find the area of the rest. Okay, now the reason why I say that is because on this problem we only have one other figure to do. There's might be some problems you work on where there's 3 or 4, even 4 figures that make up the composite figure. So just be ready. You're going to repeat step 1 over and over and over again until you've got all the other little areas. So in this case, we have a semicircle. All right. So this semicircle, and if some of us, if it helps you, you can redraw the semicircle by itself. Okay, it's up to you. You don't have to, but some people have a hard time seeing it unless they redraw it. So it's just a little extra strategy. But what I need to do is I need to go and again pull out the correct tool out of my tool chest. Right? We are not using base times height. That's a semicircle. A normal circle is pi r squared. In the end, though, because it's only a half a circle, we're going to split our area in half. Now, probably just to give us a reminder of that, I'm going to want to just put 1/2 here. That way I can divide. It reminds me, okay, this guides me, right? The formula, that's what the formula does. It guides me to not forget anything. So here we go. So the area of this semicircle, I'm going to plug in pi. The nice part is pi is always 3.14. Okay. The radius squared. Well, if I take a look here, some people may get confused, but this is why I said sometimes it helps to redraw it. Because look, if I redraw this, right here, a lot of people will go, I don't see anything that goes with that circle, Mr. Wilkins. They do. They don't see it. But sometimes when we redraw it and label it again, we realize, oh, the top of that rectangle actually is the same as the diameter of the semicircle. Okay? Now here's the problem. Be careful, right? Like we talked about the other day. We don't want to plug in the diameter. We want to plug in the radius. Okay? So if I take my diameter, 1.5, remember the radius is only half the size of the diameter. I'm going to split it in half, meaning I'm going to divide by 2. And I have 0.75. Now, to be able to solve this, now I need to follow order of operations. I always do my exponent first. Okay, again, I could punch in times 0.75, just what we were talking about in our warm-up, though. If you just happen to have a calculator with a square key, that's what it looks like right there. It's up to you. It's not a big deal. You can go either way. You'll get the same answer. But if you do have a square key, you can punch it, and you'll get your answer. So 0.5625. I'm going to rewrite everything. Now I'm going to go ahead, and since this is already in the calculator, I'm going to multiply it with 3.14. 3.14 equals, and I get this pretty long answer there. And then I'm going to now multiply it by 1/2. Or, like we've talked about, I'm going to divide in the calculator, I can divide it by 2. Equals, and here's what I get. 0.883125. That is the area of our semicircle. It's less than 1 square foot. Now, it doesn't, right now we don't want to round anything. We want to round our answer and our final answer, and that's it if we can get away with it. We don't want to round that. Leave it like that. It's already in my calculator. I'm going to leave it. Now here's what I'm going to do. For note purposes, we'll say step 3, put a little addition sign. Just like we did at the beginning of this lesson, you're going to take both areas, right? We talked about it in our vocabulary, and we're going to add the 2. So for the sake of our notes, we're going to just write this down. 0.883125. And I'm going to add 3 to it. So what this is 3.000000. In our calculator, of course, all I need to do is punch in plus 3 equals, and I get 3.883125. Now, step star, remember this is what we've been doing the last few days. Round it if it tells you to round. If it doesn't tell you to round, don't round. If it tells you to round, round it. So let's reread the directions up top. Round to the nearest tenth. So, the nearest tenth's right here, guys. So the 8, that 8 makes that 8 go up. So we end up with 3.9. And step 4, like always at the very end of a word problem like this, or even a geometry problem, put your units on there. And since we're talking about area, ladies and gentlemen, it is square feet. 3 9/10 square feet. Okay. Guys, a lot of work. All right, but like I always say, welcome to 7th grade. All right, you are now a middle school student, so this is what math's going to start looking like. It's only going to get longer. Okay, so keep your work organized, just like I did here. All right, and as long as you keep it organized, you should be just fine. Okay, any questions? I'm going to have you try a problem like this. Any questions? Okay, I'm going to go ahead, go to your homework on page 635, and try out problem number 4. Number 4, go. Okay, how many of you need more time? Okay, check with you guys in about another 30 seconds or so. Okay, checking in again. How many of you still need a little more time there? Okay. Those of you that are finished with that, find ones that are similar and you can work on those. Okay, work on your homework right now. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go. Sometimes the best way when you're sharing with someone the final answer, and if they don't match up, is to look at like what I call like your sub answers, meaning your smaller answers to your different sections, because sometimes you could be able to find, you could troubleshoot the problem because maybe one is exactly the same but another one isn't correct, right? And so that way you know, oh, you know, you did this. It just helps guide you on maybe where the problem happened, where you guys can help each other out on that. All right, here we go. Let's take a look. So I'm going to go ahead. I'm going to start off with the first figure, just following our steps here. Our first figure, I'm going to just start with our rectangle. And our rectangle, ladies and gentlemen, is base times height. Right? Pull out the correct tool. Plug it in. Our base is 15. Our height is 7. So the area of that rectangle, all right, might as well breeze right through the easy part, right? 15 times 7 is equal to 105. All right, I don't need to bother put my units on yet, all right, because we still have obviously the rest to go. So we'll put our units on at the end. Now I take a look, and here's my semicircle. Now this is kind of what I was talking about before. You say, well, Mr. Wilkins, this one doesn't have any measurement to it. Yeah, if you take a look, this rectangle here, if this side is 7, this side is 7. If this bottom side is 15, this top side of the rectangle is 15. Well, like before, that top side of the rectangle is also the diameter of the circle, or I should say the semicircle. So remember, pull out the correct tool, 1/2 pi r squared, because it's a semicircle, 1/2 times pi, which is 3.14. Okay, the radius is not 15. Half of 15 I know is 7.5. If you didn't know that, you could use your calculator. Now, so I have 7.5 squared. I'll just put in 7.5 times 7.5 equals 56 and 25/100. Then I bring down my 3.14. So I'm going to go ahead, since that's already in my calculator, I'm going to hit the multiplication button. 3.14 equals, and I have 176.625. Bring down my 1/2, and that reminds me then that I need to divide that by 2. Divided by 2 equals 88.3125, or 3,125 10,000ths. That's how you'd say that. So that's the area of our semicircle. So I'm going to now go ahead, add these two up. Well, that's already in my calculator. I'm going to press addition of 105 equals, and here's what I get. 193.3125. I now need to round and double checking. It's under the same type of heading, right? So I need to round to the nearest tenth. So the 1 makes the 3 stay the same. So 193 and 3/10. And don't forget your units. And in that one, all the units are in meters. So this, we're talking about square meters because it's area, square meters. All right, questions on that type of problem?
You wrote down 176.625 next to 1/2.
Yep.
Wouldn't that represent multiplication?
Yeah. So if I was to do this longhand, right, here's what I would have. So if I multiply, I'm going to multiply this way. If I multiply that out, it'd be 176.625 over 2, which is that divided by 2.
So even though it represents multiplication, you could still divide it by 2?
Yeah, because remember KFC? Multiplying by 1/2 is the same as dividing by 2. Okay, that's kind of where that whole idea comes from. That's why, guys, on last night's homework when we were correcting it, right? Or Tuesday night's homework, it talked about that one problem said you multiply for a quarter circle, you multiply by 1/4, or you could divide by 4. For the same reason. If I was multiplying by 1/4 here, I multiply straight across, I'd get over 4, and so you divide by 4. So it'd be the same. Okay, any other questions? All right, here we go. Let's, I think I'm going to flip the paper where I have more room and I don't have to squish. So let's take a look at problem number 5 on 635. Problem number 5 on 635. Okay, now what we're going to do is the steps are going to be almost identical. However, there is a little extra twist on this one that I want to make sure that I talk to you about. So if you take a look at that shape, it looks kind of like this. See if I can do my best to draw it. All right, it looks something like that. What we have here is we have a little right angle, and then you have this dotted line going across here with this right angle here. And they tell us that this part is 9 feet. This part is 3 6/10 feet. That dotted line going across is 7 feet. And it says this right here to what they show is this is 6.4 feet. What that is showing is that's the total. If this was like some fancy building or a car or a spaceship or something, from the bottom straight up to the top, the total height of that thing is 6.4. Okay, now here's what we're going to do. Okay, we have a couple different options. All right, but first of all, what kind of shapes do we see here? Who can tell me? What kind of shapes? What's on the very top? Yeah, we see the triangle, right? Does anyone know what this bottom shape is called? Parallelogram has the opposite sides are parallel. So that's parallel to that, but those two sides are not parallel. Trapezoid. Okay. So listen, there is a formula for that. I'm not going to worry about teaching it to you right now. If you have something like this on your test, they will either give you the formula to the trapezoid, okay, or I'm going to show you how to solve this problem without dealing with the trapezoid. Okay, so here's what I'm going to do. We'll call this step star, and on some problems you'll have to do this. Create figures that you know how to solve, and here's what I'm talking about. If I go to this point right here, where that horizontal line hits that side, and I drop a line straight down perpendicular to the base, I have now just split the trapezoid into a right triangle and a rectangle. Okay? And so at times you will have to do something like that. Now what we see here is we see 3 figures. We see 2 different triangles and a rectangle. All right? So I'm going to go ahead and follow my previous steps. So step 1, I'm going to go ahead and find the area. Let's start with the easy part, right? Let's find the area of this rectangle. So, base times height. The base is 9. The height is 3.6. So the area of that rectangle is 9 times 3 6/10 equals 32 4/10, 32.4. Okay? Now, let's deal with this little triangle we just created here. All right? That's a triangle. This is the big one where people pull out the screwdriver instead of the hammer to nail in the nail. Okay? This triangle is not a rectangle. If so many people go, oh, that's easy, base times height, okay, and they leave it like that, it's not the correct one. You're not using the right tool. You're not going to get the right answer. You're not going to get the correct results. So remember, a triangle is 1/2 base times height. We talked about that briefly on our POD the other day. So, triangle. So here we go. 1/2. Now we have some issues here, right? We don't have anything that's been labeled here, but that doesn't mean that we can't figure it out. So here we go. This part right here is the height of that triangle. And here's what I also know about the height of that triangle. It is the left side of the rectangle. And we talked about it last problem. A rectangle has congruent sides, congruent opposite sides. This being 3.6 means that that side of the rectangle is 3.6, which means the height of our triangle is 3.6. Now, this is our base. Now, I want to share something with you guys. We did this in a lesson when we dealt with one of those yellow packets. We did this in the lesson, and it was talking about, it was kind of a starter, remember, and it was about line segments. And this line segment, we can consider this bottom part, I'll kind of try to create the same length. This whole thing is 9 feet. Now, see where this line drops down? Let's say it hit right there. Here's what I know. This top part of the rectangle is 7 feet. That means from here to here is also 7 feet. So if this part of our line segment is 7 feet, ladies and gentlemen, what is this part? 2 feet. We just found out the base of our triangle. It's 2 feet long. I'm plugging in 2 over here. Now, a lot of you guys in the past, right, in recent past, like just a couple of minutes ago, saw me multiply this and then divide by 2. You can still do that. 3.6 times 2. I can use a calculator. But I'm also a little strategic, and I know about associative property of multiplication, meaning I can multiply these any which way I want. And when it comes to doing that, sometimes you can use it to your advantage, like using mental math. Here's what I'm talking about. Ladies and gentlemen, what is 1/2 of 2? Half of 2 is 4? Thank you. 1. What is 1 times 3.6? A lot easier than punching in the calculator. The area of that little triangle is 3.6. And now comes the last one, right? It's that top triangle. Pull out the correct tool. 1/2 base times height. So here we go. 1/2. The nice part about this triangle here is the top of that rectangle is 7 feet, so we already have the base of the triangle at 7. Now the height is what's going to be a little bit of a pain. But take a look. This here, all the way down, perpendicular to the bottom, I know that. What is it? It's 6.4. So if you want to, right, kind of like we talked about earlier, drawing the semicircle off to the side, I can draw this line segment off to the side and say this whole thing is 6.4 because it tells us right there. Here's what else I know. From that point to that point is what? 3.6. It's the same as the sides of the rectangle, 3.6. So what are we going to do with these two numbers to find how much this is? Whole thing is 6.4. This little part is 3.6. What are we going to do? We're going to subtract. So 6.4 minus 3.6 equals 2 8/10. And ladies and gentlemen, that's this part right here. That's the height of our triangle. Because 2.8 plus the 3.6 is equal to 6.4, the total. So 2.8 is the height of our triangle. Now that one, I'm going to use a calculator. So 2.8 times 7 equals 19 6/10. Multiply by 1/2, or like we just talked about a second ago, I'm going to divide by 2, and we get 9 8/10, the area for that top triangle. All right, and then here we go. Find out the total area. I'm going to add all three of those. So 9.8 plus 3.6 plus 32.4 equals 45 8/10. It does say round to the nearest tenth, right? But it's already to the nearest tenth. Don't forget our units. It's all in feet, so we're talking 45 8/10 squared feet.
So for the first rectangle, the area equals base times height. The length of the rectangle is 7 feet, right? And it's
Yep, thank you. I just noticed that, you guys. So it's funny, right? Because yesterday I made sure that I pointed this out to my students because this is the biggest mistake, and I'm flying through this, and that's why I just realized that my answer is not correct, because I do recognize that answer is not correct. So if we take a look, the rectangle, be very careful, because what I did is this 9 feet. Make sure you're paying a close attention what it represents. It's the complete base of this whole composite figure, right? But when I figured out the base of the rectangle, what am I looking at? From here to here, which I actually pointed out a couple of times throughout, right? Which is the same as from there to there, which is not 9, it's 7. Okay, easy fix. 3 6/10 times 7 equals, that's 25.2, or 25 2/10. So let's re-add these. We know it's square feet. Let's find out exactly how much. 25 2/10 plus 3 6/10 plus 9 8/10 equals, there we go, 38 6/10 square feet. So, not perfect, right? So it's easy to make little mistakes. That's proof right there. Okay, so be very careful on those. There's a lot of work involved. Okay. Questions? Any questions on that part right there? Why I changed it to 7 feet? We saw the base of the rectangle. Okay. Okay. All right. Here's one I want you guys to try. Go ahead. I want you to stay on that page. I want you to try out problem number 3. Problem number 3. All right. Go. Okay, how many of you still need more time? Okay, it's a pretty lengthy problem. Okay, you can, those top 6 guys, you can do, if you finish early, you could just continue on those, all right? Or at least the top 4. All right, checking in. How many of you still need some more time? Okay, about 30 more seconds, then I'm going to have you guys share. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go. Okay, here we go. All right, so you had this shape that looked kind of like this. I'm not a musical guy, but is that kind of what a guitar pick kind of looks like? Something like that. All right, so here we go. Here's what I do know. As I'm looking here, I'm thinking, we have, if I keep drawing this across, I have either I can think of it as two small right triangles, or I can think of it as a big triangle and a semicircle. Okay? Either way works. So, here we go. Now, I'm not a big fan of this problem, but it has you assuming that this point is the midpoint between here and here. And if that's the case, then what that means is this right here is also 8. And so if I'm looking at this triangle here, if I turn it like this, that's the triangle I'm going to be talking about. So if I'm doing that, if you're not seeing it, I'll make a little sketching. This is what I'm looking at. 8 and 8 and 15. So if I go to solve this, here's what I'm doing. Area equals 1/2 base times height. The base is not 8. The base is 16. 8 plus 8 all the way across. The height is 15. So if I'm going to solve this, I can do part of it in my head right there. 1/2 of 16 is 8. And now I multiply 8 and 15. If I need to, I can grab the calculator. 15 times 8 equals 120. That's the area of our triangle. Now comes a semicircle. Okay, so the semicircle I can take a look at, and if I need to draw the sketching, I can. Okay, this is 8 here, from here to here, and it says this is 8, or I at least put that. So, being the semicircle, area of a semicircle is pi r squared is a regular circle. 1/2 of pi r squared is what I'm looking at for a semicircle. So here we go. 1/2, pi is 3.14. The radius is not 16 this time. It is 8. So 8 squared. Now don't forget, 8 squared is not 16. It's 8 times 8, which is 64. So I bring everything else down. And now I'll go ahead and do 64 times 3.14. So 3.14 times 64 equals, and I get 296 hundredths. And I'm going to multiply that by 1/2, or like we talked about, divide by 2. And that gives me 148 hundredths. And that is the area of our semicircle. And I'm going to go ahead and add both of them. Now, we probably could do that in our head, right? 120 plus 100 is 220.48, 48 hundredths. And it does say round to the nearest tenth, so 8 makes the 4 go up, and we're talking 220 and 5/10, and all of it is in centimeters, so we are talking square centimeters. And there's our answer.
At the beginning, I didn't do the whole triangle. I did half of it, and then just didn't multiply it by a half.
Wait, oh, by half?
Or I didn't cut it in half because I knew that there were 2.
So it's what it sounds like is you found the area of this triangle here, and that area would have been 60. Is that what you got?
Yeah.
And then so you said, oh, well, here is a similar or a congruent triangle, a twin. So if you add another 60 to it or multiply by 2, that would be another way of doing it. All right, thanks for sharing. All right, guys, other questions or comments? Okay, we have one more type of problem that you're going to have on your homework tonight. And it's a composite figure, but it's slightly different. All right, so I'm going to go ahead and break this up. Now, what I want you to do is let's go ahead and flip back to page 634. And let's take a look at problem number 4. I'm sorry, number two. Number two. All right, number 2. Here's what it shows. It's a figure. Oops, that's kind of sloppy. Sorry. It is a rectangle. 6, 11, and then right here they have this part that's like that, and it's 4. And what it looks like is this part here is like a yellowish, and the other part is white. Okay. Now listen. Here's this type of problem. Think about it. Every other problem we've done is of the composite figure is what I called like an add-on. So you have a figure and another figure is added onto it. Maybe a couple other figures are added on and stacked onto it. Okay? Now with these problems, it says, this is the little story they give us. A triangle is cut from a rectangle. Find the area of the shaded region. Here's what I like calling these, and this is my name for them. I call them cutouts. Cutouts. They're not add-ons, they're cutouts. So bottom line is we started with this rectangle and they cut off a corner. Now mathematically, when you cut off something, what are you doing it operation-wise? Subtracting. So guys, that's the only difference in this kind of problem compared to the others. Here's what I'm going to do. Step 1 is I am going to find the area of the whole thing. So what that means is I'm going to find the area of this whole rectangle. So a rectangle is base times height. So here we go. The height of this rectangle is 6. The base, now be careful, right? This is what we were talking about earlier. The base isn't 4, even though I'm looking at the bottom. The base is the same as from here to here, which is 11. So the area of that whole rectangle before cutting it off, that corner, was 66. And we're not going to put units on yet. Now comes step 2. What is the area of, well, like I said, called a cutout? What's the area that was cut off? Well, what was cut off was this triangle right here. So the area of a triangle, remember, pull the correct tool out, 1/2 base times height. So 1/2, the base is easy. That's what this 4 is. From here to here is 4. The height, however, they don't label it over here, but because it's part of a rectangle, they label it over here. The height is 6. This is mental math. 1/2 of 4 is 2, and 2 times 6 is 12. And now step 3. Step 3 is on this cutout, we're going to subtract it, because that's what's happening. It's being cut off, right? So we have 66 minus 12. So 66 minus 12 equals 54. Don't forget, of course, about step star, about rounding, which we don't have to worry about on this problem. And then step 4, of course, always, just as a reminder, make sure you have your units on there. So the units were feet, so it is, still talk about area, it's square feet. So 54 square feet. All right, questions? Sorry. There we go, guys. On something like that during a lesson, make sure you just, I'm okay with you just letting me know out loud. All right, any questions? All right, guys, pretty long lesson because they're pretty lengthy problems. All right, they're very meaty problems, right? That has like 3 different problems in one. So there are no questions. That is area of composite figures.